This is Security Buzz, bringing you cutting-edge discussions featuring cybersecurity experts from around the globe. Before we begin, just a few quick housekeeping notes. Have a question? Click the Q&A button anytime during the webinar. Click the related content button to check out valuable resources. Stick around to the end as we're giving away a $200 gift certificate. If the presentation freezes, refresh your browser or rejoin the session. To stay ahead of emerging trends, be sure to register for our weekly newsletter. Then check out our schedule of upcoming webinars in the months ahead. Now get ready for your Security Buzz webinar.
Welcome, everyone. My name is Tim Erlin. I am the VP of Product at WallArm. I'm thrilled that you're joining us today for this webinar. We are going to talk about AR governance on AWS, specifically how to discover, observe, and control AI in production. So let's get started with the webinar. I always like to start these kinds of conversations with a little bit of context. And as much as possible, I like to draw that context from data. And so in this case, we're going to start actually with an AWS survey, the Generative AI Adoption Index survey from 2025. I think it was May of 2025, which included about 3,700 IT decision makers across 9 countries. So a pretty good subset or pretty good set of respondents. There were a bunch of questions that they asked in here, and I think you can go look at all of the details if you want separately. But there was one question that I wanted to pull out to start this conversation around AI governance with, which was the question of how organizations rank budget priorities. So we often in cybersecurity talk about threats, we talk about the threat landscape, we talk about attackers, but one of the real tests of where the priorities are for an enterprise is where they apply their budget. And it was really interesting to see that in this case, 45% of respondents ranked generative AI as a higher priority, at 45%, higher priority than security overall, which was ranked at 30%. And what that tells me, or the conclusion that I think we can draw from that topic, from that result, is that AI adoption is outpacing the security spend that's meant to govern it, that's meant to secure it. So organizations are prioritizing generative AI over security in terms of budget. And that's really interesting because it talks about, or it speaks to rather, where those organizations are placing their priorities. They're putting their money on the priorities that matter to them, and generative AI has become a higher spend item, or a higher priority spend item, to be clear, than security. Now, the flip side of that, I think, is another piece of context, which comes from another survey from Comprise this year, 2026. And this was a result that was surprising to me, I think, but also very interesting in the context of generative AI. So 80% of organizations that responded to this survey have already experienced an incident involving generative AI. Now, that's a broad question. An incident involving generative AI could mean all kinds of things. But what it tells us is that organizations are experiencing security incidents that have some connection to generative AI, whether it's an attack on their generative AI systems or an exposure that where generative AI was involved, or even maybe, if you want to interpret it broadly, attacks that used generative AI as a tool. But it still says, no matter how you interpret it, it says that the risk is real, that there's a real threat landscape here for AI, and that it exists right now. It's not a future theory. So when we combine these two things together, this spending on generative AI as a priority and the threat landscape, it becomes a really interesting picture. Now, that kind of data is useful and interesting, but I always like to marry it, if you will, with real incidents or anecdotes of things that happen in the market, because there's lots of survey data. There are lots of ways to look at survey data. But ultimately, some people respond well to data, other people respond well to stories. So consider this the story portion of the webinar. So I picked out 3 incidents. There are more than 3 to look at, but I picked out 3 incidents that I thought were interesting. And the first one, I've put the Postmark logo on it, but it's a little bit unfortunate to do that because Postmark is really, in some ways, the victim here, not a direct victim. But it wasn't something that Postmark was directly responsible for. Postmark is a tool for sending email, and they introduced an MCP server in order to facilitate that, with generative AI, make it simple. And then what happened was an attacker introduced essentially a rogue MCP server, a clone of their MCP server that mirrored that functionality. And the interesting thing about this is that for at least 15 versions of that uh, rogue MCP server, it functioned exactly the same way as the Postmark MCP server. It was essentially a clone of that Postmark MCP server. It did the same thing. If you installed it and ran it, you would have 15 versions of perfectly functioning, working Postmark MCP server. And then after that 15 versions, on the 16th version, the attackers who controlled that code base introduced a very small function, barely noticeable, that BCC'd the email that was being sent to another address. So now, after you've adopted this MCP server, which you believe is legitimate from Postmark, and it's been working well for you and you've integrated it into production, now suddenly your email is being stolen. All the emails that are being sent are being copied, blind copied somewhere else. And that's a pretty interesting attack in the space, in the AI space. Another incident here occurred with Light LLM, which is a popular LLM gateway. And in this case, it's really a supply chain compromise. There was malicious code that was added to Light LLM that collected and then exfiltrated information from the environment in which it was running, keys, secrets, configs. It also had a function to move laterally through Kubernetes, which is where it was installed in this case. So in some ways a traditional supply chain compromise, but affecting an AI, generative AI tool or something that's part of the generative AI landscape. So a different type of compromise there as well. And then there was also an incident with GitHub, prompt injection incident is the best way to describe it. And the prompt injection itself is interesting if you want to dive into the details of how this worked, but it was essentially creating malicious content inside of GitHub issues and then that allowed for the prompt. That was the prompt injection, essentially passing those into LLMs that followed those instructions. But then there was data exfiltration and more. Ultimately, instructions were carried out, and then data was exfiltrated from those environments. And it gave, whoever was the attacker gave them access to all of the other repos that person had access to. So there was the opportunity to steal an awful lot of data and exfiltrate it. So those are three real incidents that have occurred. If you want to dive into them further, I'd encourage you to look them up, learn more about them. The point of talking about these incidents, as I said, is not to point fingers or blame. I think actually anyone can be a victim of these types of attacks. We obviously want to prevent that, but the point here is to learn from them, to couple the stories with the data so that we have a realistic picture of what the risks are in the environment. And that's really what we're trying to do is learn there. And the conclusion that we come to is that AI deployment has really outpaced governance. We've seen a lot of technology revolutions, if you will, or evolutions, if you prefer, that have occurred. But I've never seen a situation where organizations are so willing to move past some of their own best practices around governance and security in order to adopt a technology as we do with AI. We're definitely seeing AI deployment occurring rapidly and faster than governance can keep up with it. And those stories are an example. The fact that you have so many organizations, 80% experiencing incidents, while 45% are prioritizing generative AI spending as their top budget priority, shows that gap in terms of real application of dollars, application of budget. It's a real challenge for those responsible for AI transformation, for those responsible for securing AI as well. So what do we do with that gap? Well, I want to start by talking about the AWS approach to that gap, which is the AWS AI Security Framework. You can go look this up with AWS. It's a valuable framework to consider how you can apply security and controls to your AI environment. And it breaks down, these three columns are three separate columns. They're not meant to map to each other, but three considerations that you need to take at different aspects. So if you start with use cases as an example, There are three use cases to talk about with AI. There's AI that answers. So that would be things like, chatbots, things that summarize, things that generate content or code. Those are AI that answers. There's also AI that connects. So you've got data retrieval, you've got knowledge bases, you've got other types of data connections. You could throw in APIs there as well. And then you've got AI that acts. So this is where agents sit, autonomous agents or multi-agent orchestration would fit into that. But those are three ways, that's three ways to think about the AI that you might have deployed in your environment. Is it an AI that answers? Is it an AI that connects? Is it an AI that acts? Now, you might have combinations of those too, right? So it's not that they're mutually exclusive. An AI agent might do all three of them. It might answer, it might connect, and it might act as well. But it gives you a way to break down the functionality that's meaningful from a governance and security standpoint. Then you can look at layered protection. And I'm a big fan of defense in depth. I think you have to apply defenses at different layers. So what are the layers that you want to consider? Um, First, I think one of the layers that people often forget about when they're talking about securing or governing AI is the infrastructure itself. Infrastructure security is part of your overall strategy for securing AI. So that means the things that your AI runs on top of. And if you're talking about AWS, that means the EC2 instances, the EKS clusters, the load balancers, the Lambdas, all the things that run inside of AWS that support the AI that you have deployed there. Identity and data security is also a big part of securing AI. Those agents are authorized, they operate with some identity. They're authorized to do things through that identity. Making sure that you understand what identities you have, how they're applied, that they're restricted appropriately, that is also part of AI governance. And of course, there's an application security angle too. As you deploy AI in production, you're building applications around AI or applications that use AI. You've got to put in place the capability to place guardrails around that AI, to do threat detection, to do incident response. Uh, you'll note that as we talk about these three layers, the security controls that we're talking about are not new or revolutionary. They're best practice controls applied to new technology, to AI in this case. And then you can also think about where you are on your journey. So part of this framework is the use cases, the layers, but also you as an organization and where you are on that journey. And AWS breaks it down into three parts: foundational, enhanced, and advanced. So foundational is really that prototype stage where you're just getting started and working to apply controls at a very basic level. As you move away from prototype to launch, you want to harden those controls and harden those systems. And then once you're at that running state in production, you want to move, from basic security to governance at scale, so that you're really managing the environment as a whole and governing that AI that's deployed. So I think that AWS framework is really useful. I think it's helpful for articulating and understanding where you are um, in terms of securing and governing AI. But for WallArm, we want to put a little bit more of a functional um, approach on top of that framework, if you will, or alongside that framework. And that's the AI control loop. So when we talk about what it takes to secure and govern AI, we think about it in terms of a loop of capabilities. And these can be sequential, but they don't have to be. A loop doesn't have a start and doesn't have an end. So you can approach them all at once. You can approach them in pieces. But generally speaking, starting with discovery is a good place to be because I won't say you can't secure what you can't see, but I think it's difficult to do. In order to secure your environment, you have to understand what's present first. Uh, and then after that, you really want to understand what those entities, if you will, are doing. And that's the observe part of the control loop. Being able to see the behavior. Inevitably, when you start looking at behavior, you might start finding behaviors that should be prohibited or that are malicious. And so that brings in the enforcement piece of it, stopping bad behavior. And then finally, you can move on to governance, which is really the tracking and the reporting and the compliance piece of it. Governance does tend to be a more mature operation, but that doesn't mean that you can't start there as well. As I said, it's a loop, but you do need all four pieces to complete the loop. And we're going to talk about each of them in sequence for a moment. starting with discovery. Even though I said there's no start, I'm still going to pick a start. We'll start with discovery. And this is really about answering the question or the statement, responding to the statement, we don't know what AI is running in our environment. And I want to point out here that this isn't just what LLMs are we using or what agents are running, because that's part of the picture. The list of agents is part of the picture, but it's not the whole picture. We talked a little bit about what the three use cases in the AWS framework and how they can be combined. When you look at those three use cases, you start to see that it's not uh, just an agent. It's an agent plus all of the tools and resources it connects to. So you could see here we've got agents, but you've also got MCP servers, you've got model providers, you've got data sources, you've got the users themselves who interact, who start those sessions with a prompt, for example. And then we talked about the importance of infrastructure. All of those AI workloads and tools that you're running, they're running on top of some kind of infrastructure. And if we're talking about AWS, that means VPCs and EKSs, and APIs. You've got identity mixed in there, you've got lambdas mixed in there. So the challenge here is that we see organizations with engineers who stand up AI services. Security doesn't know about them. The priority is velocity. So we're going to get things up and running. Security finds out about it later. You might also have serverless functions that are hitting model providers that aren't approved. Again, because of the priority of velocity, velocity, if you will. And then MCP servers, we talked about that example of a rogue MCP server. Uh, that need to connect and build those connections can result in MCP servers or other tools that no one has reviewed. And in a large organization where you have multiple AWS accounts at scale, the time between deployment and security knows about the deployment, it's really compounded across that landscape. So when we talk about discovery, what does good look like? What are you trying to achieve here? So first of all, inventory can't be a point in time. It has to be a continuous inventory of infrastructure and the AI workloads that run on top of it. That discovery, that inventory has to include the AI elements themselves, the LLMs, the agents, but also the tools, the MCP servers, the data sources. You have to get the full picture. And you have to be able to identify shadow AI. So some mechanism to say this should be here, this shouldn't be here, this is sanctioned, this is known about but not sanctioned, this is unsanctioned. However you want to characterize that, you need that ability to understand what's in the environment to have a fully functional discovery capability. So let's move to the second step, right? Or the second element in the loop. We're talking about observability or observe. And this is really responding to the statement, we don't know what our AI is doing. So now you know what's there and you can see that list, but you can't see what it's doing. Okay, well, the next step is to understand what it's doing. And here it's important to understand that an AI prompt is more than, an AI workload is more than just a prompt and a response. It's all of the things that are connected between the two. So if you're looking only at prompts and responses, like an AI gateway, for example, sees a prompt, sees the response, useful tool, but it's missing all of the interactions that occur between those two bookends, if you will. So that interaction is the user identity that started it, and all of the user identities that occurred or are used throughout the interactions, the prompts, the APIs, the tools, the resources, and the LLMs and agents, and the connections between them. So if discover is the inventory, this is the connection behavior. What does good look like here? Well, so it's detection of that full interaction, not just here's a prompt and here's a response, but here's a prompt, here's the tool intent, here are the tools that were accessed, here's the APIs that were accessed, here's the data that was retrieved. It also needs to include PII identification and egress detection. Here's the PII that exists in these interactions, and here's where PII left the environment to go out to an external model or an external MCP server or an external API. And then, of course, tracing those interactions back to the original identity or user. So understanding that this API call that an agent made actually started with this user's prompt, so that you can make that connection for the full trace. And that's what gets you observability for those AI workloads and that second step, second element in the AI control loop. And as I said before, once you start looking at behavior and what's actually happening, what your AI is doing, you then probably want to work on or start enforcing some of those behaviors. Now, this is really a response to the statement, we can't stop bad AI behavior in real time. And I struggle with how to articulate this one because from a security perspective, we really want to talk about attackers and malicious attackers, especially malicious intent. But when we're talking about generative AI, there are a set of behaviors that aren't malicious, that are just rogue agents, rogue AI. You could talk about hallucinations but we're talking more about connecting to tools that it really shouldn't be using, or tools that the agent uh, tools in ways that the agent shouldn't be using them. So those risky tool calls. We're also talking about the movement of PII. It may not be malicious, but you might have an agent send PII to an external API or to an external LLM as part of trying to get its job done, so to speak. So we really need to talk about, if we're talking about uh, enforcement, we're talking about blocking things like prompt injection, jailbreaks, but also things like PII movement, risky tool calls, other more policy-based behaviors as well. So what does good look like here? If you're looking at blocking bad behavior, what do you want to account for? Well, you want to account for the ability to block sessions instantly. So can I actually stop something from happening, or am I just detecting and reporting on it? And this is an important distinction because detection is only part of the puzzle. You can put in place a tool that will identify bad behaviors, identify incidents, but leave it up to you to do something about them. Or you could put in place a tool that actually blocks those behaviors, blocks those incidents, prevents the incidents from happening. So that blocking piece is very important. And then policy-based blocking is also important. Can you put in place a policy for a particular agent and block its behavior when it's outside of that policy? And WallArm does that with behavior certificates. The standard is called A2AS. You can find it at a2as.org, where we've implemented behavior certificates that you can build from behavior in the environment. So watch an agent and its behavior, build a certificate, and then prevent that agent from going beyond the bounds of that previous behavior. You can, of course, create certificates in other ways. You don't have to create them from behavior, but that ability to put in place a behavior certificate to bound your agent and its behavior is a powerful tool for stopping bad behavior from agents and from AI. So then finally, we get to govern. Now, governance is an interesting term. It's being overloaded in the market, I would say. And I've put up here on the slide a list of compliance standards. The EU AI Act is the one that gets used as the most common example here. And there are some provisions of the EUA Act that are already in place, some that are coming to enforcement in August of 2026, and some that are likely to be pushed out. I don't think that's finalized yet. So you're going to see enforcement come in waves here. The real test is, of course, when auditors start asking questions. And that may not become a serious threat for most organizations until there's actually an incident or a fine. But it's not the only place that compliance matters for AI. Anytime you're dealing with PII or sensitive data, you potentially run into GDPR. And so GDPR in its current form does apply to AI as well. And then there's also up and coming legislation or regulatory frameworks that will be audited at some point in the future, from Colorado as an example. And of course, there are a set of voluntary frameworks, the NIST AI Risk Management Framework, um, ISO 42001. SOC 2 has some relevance here as well. And I've mapped them to the different elements um, of the AI control loop. What's important here to understand is that compliance and implementing controls and validating controls are not the same thing. So when you're putting in place a control, understanding that it helps you achieve compliance with a particular standard is important. Being able to demonstrate that that control is in place is part of validation, is part of going through an audit. So even if you're not sure exactly how audits are going to occur, and you can't really demonstrate compliance yet because you don't have a framework or an auditor to demonstrate it to, you can still put in place the controls that let you that really prepare you for that future compliance state. And I think that's an important consideration we have with AI and where we are with generative AI. It's moving so quickly. We talked about that velocity. We really want to be prepared for the audits that are coming, to be prepared for the auditors that might show up knocking on your door in the future. And the AI control loop is a great way to do that. Having some ability to demonstrate compliance is a great way to do that. Making sure you've put in place the controls is a great way to do. So finally, let's talk a little bit about how AWS and WallArm can be combined to deliver capabilities here, because it really is a better together story. We're talking in this webinar specifically about AI governance on AWS, and AWS provides a set of powerful tools for deploying and securing AI. You've seen probably a number of improvements and changes with Bedrock. Bedrock is a really powerful tool for enterprise AI and for production AI deployments. And there are other tools there, EKS and SageMaker being two of them. But that ability to run AI through Kubernetes and AWS really gives you foundational capabilities for AI. Um, AWS also comes with a number of native security signals. So GuardDuty, Inspector, the IAM Access Analyzer, CloudTrail, those all flow into Security Hub, and that's powerful capability for instrumenting your environment where you're deploying AI. And of course, AWS provides the scale and also the identity and the networking infrastructure for running AI as well. On the WallArm side, we provide that capability for the AI control loop, as you can imagine. Uh, we start with the ability to discover all of that AWS infrastructure across all of your AWS accounts with WallArm infrastructure discovery. That's really foundational, understanding what you have in the environment, being able to filter and search and see how things are connected, being able to look at how configurations are changing. So if someone spins up a new EKS cluster, or if somebody changes the configuration of a load balancer, all of those things will show up in WallArm infrastructure discovery. You can even get a graph that you can drill into and filter of exactly how all of your AWS assets are connected and deployed across multiple accounts, across all of your accounts. On top of that, WallArm's AI hypervisor provides the ability to discover all of the components of your AI workloads, the agents, the LLMs, the MCP servers, the APIs, all the things I mentioned, is part of that discovery piece, including the shadow AI identification as well. And then really the core of what WallArm is doing here is in AI hypervisor and our runtime AI visibility. So the ability to trace AI interactions, AI workloads from the initial user and prompt through all of the connections to the tools that those workloads are using and connecting to, and trace that back to that initial identity. That's core technology that services the observability and then gives us the ability to do that inline enforcement, the ability to block sessions that are malicious, that are detected as being an attack, to block sessions that are exfiltrating PII, whether it's accidental or intentionally malicious, and to implement those behavior certificates that I mentioned, the A2AS certificates that constrain the agent behavior to a specific set of tools and capabilities. So the AI control platform really partners well with what AWS offers, and gives you the ability to get that better together story and complete that AI control loop, which is what we're after. So let me leave you with some final takeaways. If you haven't been paying attention up to this point and you want to just catch up, these are the things that I want you to walk away with. First of all, everything starts with discovery. So understanding what you have in your environment from infrastructure up to AI workloads and agents, that's where you want to start, is with that discovery piece of it. And both AWS and WallArm can help you there. AI governance is about more than AI. So this was the observability conversation we were having. If I want you to walk away with two things, the second is that when you talk about AI security, when you talk about governing AI, it's not just the agent or the LLM. It's all of the things they connect to that are important. Finally, detection is not enough. Tools that, not finally, secondarily, second to last, detection is not enough. There are lots of tools out there that will tell you about bad things in your environment, but you want to look for tools that let you actually do something about it, that let you block the bad activity or that you block the malicious attacks. So when you're looking at capabilities or tools, whether you already own them or you're looking for something new, ask the question about, great, that information is interesting. What do I do about it? Or more importantly, what do you do about it, vendor? Because you're looking for a vendor that does more than detection. And then last but not least, compliance is coming. So we want to be prepared for the compliance requirements that are going to come forward. If you don't have auditors asking you about AI today, that's great. Consider yourself lucky, but now is the time to prepare for those audits and those auditors by understanding what controls you need to be put in place and then being prepared to provide the evidence to auditors as well. So with that, I want to thank you for spending these few minutes with me. I hope it was interesting. I hope it was worthwhile. I'm going to leave you with this link to the AWS Marketplace and WallArm's infrastructure discovery tool. As I said, everything starts with discovery. WallArm's infrastructure discovery capability is that piece that discovers your AWS, all of your AWS assets across or resources across all of your AWS accounts. There is both a free trial and a free tier, so you can get started for free and see what's available in infrastructure discovery. And then if it's valuable to you, you can move on to pay for it. Or if it's appropriate for your organization, you can stay on the free tier and continue using it that way. So with that, I'll say thank you again for spending time. I appreciate the time. I hope it was worthwhile for you.
All right. Thank you so much, Tim. Now, folks, we do have one last item to take care of before we wrap up this webinar, and that is selecting our lucky gift card winner. So without further ado, today's winner is Tyson B. Congratulations, Tyson. You'll be hearing from me, Anna Weissenberg, and only me within the next 24 hours for information on how to claim that gift card. And with that, on behalf of WallArm and Security Buzz, we thank everyone for attending our webinar today. Thank you again, and take care.